So I think people will start coming in like as the session progresses, and since we are like about 5 minutes into the schedule start time of the session, I think we can get started.
Yeah.
So yeah, okay. So just to set the context for this inaugural edition of this AI for Social Good speaker series that we plan on having at LIRNEasia. So I think in a global context, it's undeniable that AI is having a moment, and it has been probably having that moment ever since the release of ChatGPT in November 2022, and it looks like there's nothing else anybody can talk about almost. And like ever since, there has been other remarkable developments of AI as well. Yeah, there are more public-facing initiatives like Midjourney and Sora, where it has been democratized, like AI has been democratized for people to make everyday use of the tools that are available through the development of AI. And on one hand, there's undeniably a lot of hype, a lot of unwarranted hype. Almost everybody thinks that, or rather, like at least a fraction of the population believes that they can probably solve everything, and it might potentially even take over and become sentient, and it will be the end of the world. So there's hype on one hand, there's doomsday on one hand, and I think there's little room in the middle for grounded conversation. And I think that grounded conversation is important for Sri Lanka as well, particularly because even though perhaps not to the same degree as the global conversation, Sri Lanka is also quietly having its like own AI movement. So we do have initiatives that aim to introduce AI into the school curriculums. There's a lot of chatter and reporting around that. And there's also a national strategy for AI that is being worked on. There's budgetary allocations from the government that are trying, that aim to get certain initiatives going in certain sectors such as education, health, agriculture, etc. So we felt as LIRNEasia that it's time for us to have a more grounded conversation on what's really possible with AI, what are the real dangers of AI, and how do we separate the hype from the reality, and have a meaningful discussion which should orient us properly as we march towards like hopefully minimizing the downsides of potential downsides of AI while reaping as much as the upside of it as possible. So for those of you who might be unfamiliar with LIRNEasia, so we are a public policy think tank. So we operate across multiple sectors, everything from digital access and rights to health to disability. We cover a range of sectors across several of the countries in Asia Pacific region. So we are based off Sri Lanka, Colombo, but we operate like across the region as well. And since about 2013, we've been what was formerly called big data. We've used big data techniques, and our team was also formerly called the big data team, which is now called the data algorithms and policy team. So we've really been looking at how do you take some of the research being done by academics and other people who advance the frontier, but take those research, take those algorithms and methods and really apply to policy problems that we see in the sectors and the regions that we operate in. And so when it comes to natural language processing, we've also done some work in the past, which I'll very shortly get into. But like really, the reason for today's session and choosing this as our topic was really me observing Ramith being super enthusiastic about the project Aya on all the platforms that I was part of. So Ramith, who will be a speaker today, and I was curious and I reached out to him just to get to know more about the project. I was super interested and almost heartened to hear the global scale and the ambition of the initiative, and also trying to address a very specific problem. For I mean, for everybody who thinks like ChatGPT can magically transform everything that we do in Sri Lanka, what we don't realize is that one, ChatGPT is available in English, and most of Sri Lankans do not speak English. It's either Sinhala or Tamil. And the capabilities of Sinhala and Tamil when it comes to NLP is not, let's say, up to par compared to other more heavily resource languages. And even when it comes to Tamil, there are distinctions between what's locally spoken and maybe what's spoken elsewhere, perhaps in South India. There are nuances and important differences that need to be taken into account when it comes to deploying Tamil NLP in local settings. So there has been, uh, this is so Nitanta, who's also part of this call. He has done a comprehensive mapping of all the tools and research that are available in Sinhala, and he goes into a lot of detail. So one of the things that he highlights, as you can see on the uh, screen itself, is that even with such initiatives, like Sinhala still remains a resource poor language, which has neither the economic drive nor the number of speakers for it to become capable to the same degree that some of other languages or like heavily resource languages are enjoying. So there are we really need to figure out creative ways to get this working, AI or NLP for Sinhala. So the answer is no, ChatGPT will not magically solve problems for Sri Lanka, but hopefully there are other ways where we can bridge the gap and get to a stage where like we can do some of these tools. And even us, we were able to do a minor contribution some time ago, where we built some resources for Sinhala NLP, building a corpora and stop words from colloquial Sinhala using Sri Lankan Facebook data. And really, the purpose of the session is one to understand like how Aya has thought about this problem. How do we overcome the issues of under-resourced languages? Not just Sinhala, it spans a whole host of languages, and you'll get to hear more about it in a minute. And also what the future looks like, both in terms of what they foresee to be the general future of natural language processing, but also how this work can be leveraged and built upon and taken in different directions to bridge this gap and democratize natural language processing and AI. So that's really the objective of this session. So just we will share some of the resources and material of the Project Aya. This is just a remarkable overview of the massive efforts that has taken place over the last year and a half by the amazing folks at Cohere AI on the Project Aya. So today we have three fantastic speakers. So we have Shivalka, who is a researcher on Project Aya, and she was also the Asia lead on the project. And we have Viraat, who was a research scholar and I believe the second author of the Aya model paper that's out there. And we have Ramith, who served as a language ambassador on the Project Aya and who marshaled the troops in building high quality, fairly decent sized uh, uh, resource pool for Sinhala for them to be able to do the work that they do. So I'm going to stop there and let you guys take over, and you can present in the whatever the order you like, and we'll have about 30 to 40 minutes of presentation from you guys, and hopefully after that we can have a question and answer session. We will take it by ear on how we want to proceed on that. Maybe we'll open it with like a question from the audience, and I'll have a few questions myself. So I'm going to stop sharing my screen, and when you guys are ready, you can start.
Yeah, thank you, Merl, for the great introduction and starting the session. I'll take over now and I'll just quickly present my screen. In case of multilingual AI, the progress has kind of neglected vast majority of languages that are spoken in the world. There are like some 7,000 languages in the world, but majority of the progress in NLP research has focused on a few handful of languages, which are primarily from the West. And this is visible in the paper publications. If you look at any top conferences and journals, you will find that most NLP papers focus on these few handful languages and not the low resource languages. And the reason for that has been because the major source of the data for training these models has been the internet. And the internet is dominated by speakers from the West. And so there are only a few handful of languages, you can count them on your fingers, that whose data you will primarily find on the internet. This forms the basis of training of these models, and that is why naturally the progress in NLP has also favored these languages and not the languages that are spoken in other parts of the world, especially Asia. So without robust multilingual data sets to train, there are a lot of risks because obviously you're cutting down a huge population of the world from this amazing progress that we see with AI models like ChatGPT, right? If ChatGPT cannot speak properly in Sinhala, then people from Sri Lanka cannot enjoy the capabilities of a model like ChatGPT, right? And there are chances of, because this data is primarily trained on data sets that come from the West, you naturally end up introducing biases of that data. So if you ask, if someone from Sri Lanka asks some question about some food related queries, it might the model might start talking about pizzas and burgers because that's primarily what uh, because it's seen data that talks about that kind of food, right? It might not know about local dishes that are made in Sri Lanka. So that's the kind of biases I'm talking about. And there's also research that shows that because these model, I mean, there's also a performance divide for languages with limited data sets. You end up paying more for the model generations because the tokens that are produced for these low resource languages are more, and hence the generation cost ends up being more. And you can also end up introducing security flaws. So there are a bunch of risks associated with training multilingual models without good data sets. So with this bigger, broader picture in mind, we wanted to, our target was to release an open source data set and model that could work across 101 languages. And we knew this was an ambitious goal, and the way to do what we decided to do this as an open science initiative so that whatever model and data that we release can be can be used by everyone in the community. And uh, and so we gave ourselves 1 year and we launched the Aya Open Science Initiative. And we kind of started working on this project. And so, like I was mentioning, there are a bunch of uh, risks that we can introduce if we don't have good quality data sets. But there also comes a lot of challenges with building good multilingual data. First of all, there is not enough good data, and whatever data is there is not of good quality. And there is also lack of qualified local native speakers who can work on contributing data for these low resource languages, right? So these were the three primary challenges that we had when we launched our open science initiative. Um, And so to address these problems, the way we went about tackling it was, like I mentioned, we started an open science initiative and we invited everyone to contribute. But how people were going to contribute was through an annotation platform that we had built specifically for the project. And this user interface allowed us to onboard speakers from for multiple languages for the project, and they could come in, log in, sign up through the platform, and start contributing for data for their language. And so over the course of the project, we had about 3,000 people that eventually ended up joining the project through the platform. And we had made sure that our platform is easily accessible through web as well as mobile. And we saw a good split of users who were contributing to the project, both via the web browser and the mobile uh, devices. And initially, we had only Discord sign up, and later we realized that Discord is not the preferred sign up medium in a lot of parts of the world. So we later introduced Google sign up, and after that, we saw a lot of good number of speakers who joined in, especially for low resource languages as well. So this is just a small graph depicting from where all like users we saw. We had people from 119 countries that joined the project, and we had a good split of users across different age groups and genders. And our annotate so once you came to the Aya annotation platform, there were three tasks that you could contribute to. And one of the first task that was there in the UI was a task called rate model performance. And here basically a user was shown a prompt and a completion, and the idea was that the user could basically, they would see a prompt and a completion in their language, and the idea was for them to read it and edit it. So if you felt that there was some grammatical mistake, or if the response to the prompt was not of good enough quality, or if perhaps the prompt did not contain clear instructions, you could basically give a rating to the prompt and the completion, and then you could edit it out and make it like proper. So this was one way that we were collecting data for the project. The other task in the UI that you would see was a task called contribute your language, where basically you could choose your language and then you could create prompts and completions from scratch. So you could basically submit food recipes, or like any book, the summary of some book, or you could basically create any prompt and completion, any kind of question answers that you think might be useful for uh, a model in your language to answer. You could create those kind of submissions and submit through the platform. Then there was a third task in the UI called review user feedback. This task basically, in the rate model performance task, what you were doing was you were basically rating prompts and completions and editing them and improving them. In the third task, basically, whatever you were editing and improving upon, someone, another contributor from your language could view your submissions, and they could basically rate your submission, right? So this task was basically to help us get to basically help us reward annotators who were uh, making good contributions. And there was like a leaderboard that we had in the UI. And so any task that you contributed to, you would get points basically. And based on those points, we were also calculating another score called the Aya score, which I'll talk about in the coming slides. Um, yeah, so and basically we wanted the UI to be very easy to use. So there were drop downs which allowed you to easily switch between tasks, or easily switch between languages, easily switch between read and edit mode. We wanted to support languages that were both left to right, or right to left, and like there were like clear instructions in the UI about what task was expected to do. So yeah, so it was really important that anyone who came to the platform could easily come and start contributing, and we did not want it to be very NLP heavy. Basically, we wanted anyone with no technical expertise also to be easily able to come and contribute to the platform. So we kept the UI very minimalistic for that reason. So this is the Aya score that I was talking about. So basically, this score kind of helped us um, evaluate the contributions the people were making. So basically, like I mentioned, people were making two important types of contributions. One is they were editing contributions, and the other was they were submitting original contributions. So this was just a simple score that we were computing to kind of get a sense of the quality of the submissions of the users, and based on this we would determine uh, we had prize categories, and we would kind of reward contributors who contributed to the project with some prizes. So basically, that was the purpose of this score. And so because of the contributions that we collected from the Aya UI, we eventually were able to create the Aya dataset. And the Aya dataset basically contains the original annotations that we collected through the contribute your language task, and the re-annotations, which is basically the edits of the prompts and completions, basically the modified submissions. Um, and we had a good mix of high resource, mid resource, and low resource languages collected through the UI. And yeah, so that's how we collected the Aya dataset. Um, and the criteria for inclusion was quite simple, because we were all the original annotations were included. For the re-annotations, so you saw in the rate model performance task, right? The user was already seeing a prompt and a completion, and then they were modifying it. So that's what I mean by re-annotation. And so for these re-annotations, they were taken. The original example was taken from existing data sources. So only if the user modified it to a certain extent, we had defined some edit distance criteria, which you can read about in the paper. So only if they uh, basically satisfied our edit distance criteria, we would include that re-annotation in the data set. And that is how we ended up with a total of 204,000 submissions for the final Aya dataset that was released. Apart from the Aya dataset, we also released a dataset called the Aya collection, and this is a much bigger dataset. This contains 530 million data points, and the way we created this was by translating existing datasets, primarily from English to other languages. So we had 101 languages that we were looking to collect data for initially. And so we took some 19 high quality data sets from existing collections like XP3, FLAN, Dolly, and some other data sources. And we translated these into the 101 languages that we were looking to cover as part of the project. And the other approach was by templating existing data sets. So basically, if there was a existing data set in Sinhala, we would basically like create a prompt template and like basically remodify that data set into a instruction style data set, so that that data set would be converted into a prompt completion kind of style of data set. So that's what we mean by templating data set. And so through we ended up templating about 44 data sets, and that is what is included in the Aya collection. And with this approach, we ended up with about 513 million data points that cover around 114, 15 languages. And yeah, and these languages cover a wide range of tasks from summarization, translation, paraphrasing, and lots of other tasks, but broadly ranging across three main categories, that is QA, natural language generation, and text classification. And apart from this, we also built a evaluation suite, which consists of three data sets, basically. The reason we created this was because there are lots of evaluation data sets for task specific, like for task specific data sets, like for translation, or QA, etc. But there are very not good quality data sets for open-ended generation capabilities of LLMs, especially within a multilingual context. And so that's why we wanted to create this evaluation suite. And so this consists of three data sets, basically. One is the human curated examples in a specific set of languages. So basically, from the Aya dataset itself, we created a train and test split. And so the test split of the Aya dataset refers to the human curated examples that we're talking about here. And the other was there is this popular instruction style dataset called Dolly that's used a lot. And we took about 200 samples from the Dolly dataset. And uh, we basically translated them into 101 languages, and that also were part of the test set that we created, evaluation suite that we created. And the third part was the human post-edited translations. So basically, out of we took the translations that we got from the after translating those 200 data points from the Dolly dataset, and we basically got some human annotators to basically improve the translations that we got from the for the Dolly dataset. And that was done for 6 languages, and we got around 1,200 instances. So yeah, these were the three data sets that form our evaluation suite that we released as part of Aya. And so basically, these are the Aya data sets. One is the human curated data set that we collected through the Aya UI. That's what we call as the Aya data set. Then we have the Aya collection, which we created through a automatic process by templating and translating existing data sets with 513 million data points. And the final is the Aya evaluation data set, which covers 101 languages and has around 23K instances. And with that, I'll hand over to Ramit.
Yeah. Thank you, Shirley. So in the next couple of slides, I'll give a brief intro on in the context of Sinhala and Tamil, how the number of examples that exist in these data sets. So considering the Aya data set, we have like as Shivalka mentioned, we have original annotations and re-annotations. So in the re-annotations, the peers have gone through some examples someone contributed, and they have modified it. And as Shivalka mentioned, there's like a edit distance calculation that we are looking at to see if that's a meaningful edit. So from my perspective, re-annotations are like very good quality data in the sense that peers have reviewed it. So in the context of Sinhala, I observed that there are a lot of like spelling mistakes corrected by peers. Um, so in Sinhala re-annotations, we have like 4,000 re-annotation, and in Tamil, it's like 6,000. And in both Sinhala and Tamil, in the Aya collection, there's like 4 million examples. So in the context of Sinhala, again, since those are like machine translated, those might not have the quality that the Aya dataset has. So there's definitely like possible room for improvement in terms of like Sinhala and Tamil-Nati research. Yeah, so if you go to the next slide, I have made actually a Google Colab notebook where you can go through, quickly glance through the examples. So in particular, the example code has a filter to just get the Sinhala or Tamil subset. And also, if needed, like you can filter out the re-annotations only or original annotations, so on. Yeah, so if someone is like hoping to get an idea about the dataset statistics and like maybe doing some analysis on it, this notebook would be a good place to start. So in the next slide, I just want to mention a possible research direction that could be there for Sinhala. So this is just something I observed. Definitely, there might be better approaches. So in Sinhala, what I've observed is sometimes people might not tend to like type the Sinhala script to a chatbot. They might like use what you call Singlish, or I think there might be a better word for that. So a possible direction would be like if you want to train a, instruction style model that works for Sinhala, Singlish data. Basically, we are typing the Sinhala words in Latin script. So if we want to build something like that, a possible direction would be to like reverse transliterate the Aya dataset. So basically, I have like shown example here from the Sinhala subset. So it's in the Sinhala script, and maybe we can like reverse translate it to get it to like the English format of typing. But there's definitely, there might be ambiguity in doing this in some words. So I saw a nice repository by this author on GitHub where like usually the transliteration happens from English to, Singlish to Sinhala, but this is nice place to start off if you want to build the other way around. Yeah, so I'll hand over to Viraat to talk about the Aya model and the where the lots of great things happen.
I'm going to be talking about the Aya model, how we trained it, what we compared it to, how we evaluated it. And finally, I'll point to some resources that you could go look at, maybe the model or the data set that you want to use. So firstly, how do we build a state-of-the-art multilingual model? We want to fine-tune a pre-trained base model using instructions in 101 languages. That was our goal. And the way we achieved this is we carefully selected different data sources and looked at the quality, pruned them, and then weighted them differently to create a fine-tuning mixture, which we then use to sort of instruction fine-tune our model. There were 4 main goals that we had with this model. We wanted to expand language coverage. The previous state-of-the-art language coverage for instruction fine-tune model was 46. We wanted to more than double that to 101. We wanted to have a broad multilingual evaluation suite. So like Shivalka mentioned, we leveraged the Aya evaluation suite and also looked at some other different evaluation categories. We wanted to have leading multilingual performance compared to all open source models that were there. And then finally, we wanted to see what we could do for multilingual safety. We look at safety mitigations and see the model's performance for bias, harmfulness, and toxicity across a bunch of languages. So this is a nice overview of the model. I like to keep this image in my head whenever I want to explain the model. So the Aya model is based off, so a lot of our decisions were driven by having 101 languages in this model. So the pre-trained base model that we use is a model called MT5 that was released in 2019. I know this is slightly older and it's probably like decades in the field of AI to choose a model from 5 years ago. But the reason we did was it supported 101 languages. Newer open source models either support English mainly or a bunch of high resource languages. So we wanted a large base. And we chose the largest of the MT5 family, which is a 13 billion parameter model. Then we had a bunch of data sets, which I will go into detail, and a large evaluation suite. But this is roughly the whole image of the Aya model in one slide. If you are wondering what an IFT example looks like, there's a prompt, what day is followed by Saturday, and a completion. And the way we generate IFT data sets is we take existing data sets and add this prompt to it. So it could be things like a question answering data set, you give the question and answer, or it could be a summarization data set where the prompt would be summarize the below text for me and the completion will be the summarization. So let's talk a little bit about the data that went into the model. We split these roughly into 4 categories. One which we call templated data, human annotations, translations, and then synthetic data. For templated data, we took existing instruction fine-tuning data sets that were multilingual. XP3X is a good example. That data set covers 280 languages and has about 600 million examples on its own. We subset that to the languages that overlap with MT5, and that results in 99 languages from MT5. Then we use Aya collection to get, I think, 61 languages when you overlap with MT5 supported languages. Data provenance is an initiative led by some folks out of MIT across multiple institutions where you can use permissively licensed data. So we pick some data sets from data provenance to give task diversity. So these were the ones which introduced few short, chain of thought, those sorts of tasks. Human annotations was the Aya UI data set, about 200,000 examples. Automatic translations and synthetic come from the Aya collection. So here you take a bunch of data sets and you automatically translate them to a bunch of languages. We used, I think, NLLB to translate this model, translate these data sets. And finally, we do synthetic data generation. What we do is we take shared GPT, which is a collection of prompts and completions from ChatGPT for a few months when the data was publicly available. We take those prompts and we get Cohere's command model to complete them. We do some filtering and we translate that also into 93 languages. After filtering in English, we have about 65,000 examples, multiply that by 93, and that gives you the size of that data set. Overall, across all of these data sets, we have 101 languages and about 200 million examples that we have in our fine-tuning data corpus. But we were worried about some of the quality of these data sets, especially off-the-shelf IFT data sets like XP3X. So what we did was, as researchers, we got together and we actually manually annotated a bunch of these data sets to remove, based on completion quality, based on whether the answer was actually correct or not, and also looking whether the prompt was relevant to the content in the question. And so we did a bunch of pruning, and this actually, as I'll show in later results, really helps a lot, especially in generating longer completions, but also improving the quality. And so you can see on this slide how much reduction we had in prompt templates, but also instances and instruction length. So we saw, almost an 8% increase in English instruction lengths, but for multilingual, we saw close to, I think, 17%, which is quite large. So I mentioned on the previous slide that we have a 200 million data examples. We have a finite training budget. We can't train on all 200 million of these. So we also want to be careful in picking which of these we give weight to. So for all the different sources that we spoke about, on this graph, the way you read it is the red bars are all the natural distribution where you don't do any weighting. So here we do some weighting for each of the subsets. If you remember, I said templated, human generated, automatic translation, and synthetic generation. So we weight each of these sources differently. And you can see some of the weighting schemes we tried and how they changed. It's very important to balance having good multilingual performance along with having good task performance. So For example, you could see for template heavy, which is the green bars that you see, we upweight the data sets in the template collection. And that results in a shift you can see where some of the tail languages are slightly more, some of them specifically are slightly more represented. Then I'm going to talk about eval. So we had 4 different eval categories. So we were looking at zero-shot unseen tasks. So these were tasks that were not seen at all during training. So both the task type and the data set were completely held out. Then we had general purpose. So this was MMLU. So this was to test the model's ability to handle diverse situations. Then we had in-distribution generative tasks. So these, the models had seen the train splits, but hadn't seen the dev test splits for these. So this is generative as well. So it's like translation, summarization, and QA. Finally, we had open-ended generation using some of the Aya eval suite. We got human evaluators to check win rates and as well using GPT-4 for that. Finally, we had some safety benchmarks that we did both for toxicity, harmfulness, and gender bias. Overall, these covered 99 languages across all these data sets, and we had 6 different evaluation types. So this is what the eval results for unseen discriminative tasks looks like. You could see that our Aya models, which are at the bottom here, you could see the different sort of weighting schemes performed the best across all the benchmark, all the baselines that we had, and they outperformed them by quite a bit. Sort of similar story for MMLU, but this is multilingual MMLU where we have 26 languages, I think. The other baselines here, Okapi is 25 shot, MT0, MD0X, and Aya are all 5 shot. Finally, for in-distribution generative, so this was Flores, Excel, Sum, and TidyQA. We had across languages, this was the sort of performance that we were able to get. Again, we had sort of state-of-the-art performance for these for multilingual IFT models. Finally, you'd see that not always the STAR model, which is translation heavy, is the best model in terms of these metrics. But this is the model that we release. And the reason for that is that we found, oops. Okay, yeah, for open-ended generations. Slide. Yeah. Sorry about that. Yeah, so we see if we split this by resource, language resource. So HR, MR, and LR here are high resource, medium resource, and low resource language. We see a larger improvement in the medium resource and low resource languages. In terms of percentage, the low resource languages gain the most improvement. And medium resource and high resource follow after that. And this we've seen across all the 3 different task types that we just spoke about. For open-ended generations, this is Aya model versus MT0X, both across human and GPT-4 eval. Across all of these, the Aya model performs the best, but what's interesting here is for English versus Bactrian-X. GPT-4 picks Bactrian-X most of the time. We believe that that's basically because Bactrian-X is of Llama base, which is much newer and better than the MP5 model that we were using as base. Finally, we also looked at the contribution of each different data source to performance, and you can see a pretty interesting pattern here. So for discriminative tasks, the templates add the most performance. For generative tasks, particularly Flores, which is a translation task, the translated data sets add the best. And for win rates, which is generative quality, all of the data sets are super important. Yeah, as I was saying, the reason we release Aya translation heavy is that there is a tension between the metrics and the open-ended generation performance. We find the generation quality is much better for the Aya translation heavy than the template heavy, and completion lengths, as you can see here, versus MT0 as well are quite in favor of the Aya model. I'll briefly touch upon safety. I know we're running short on time, but I'll just wrap this up in 2 minutes. So we perform safety context distillation to create a safer version of Aya, and then we curate multilingual toxicity data sets and evaluate the level of toxicity on those. We also look at gender bias in translation tasks. So what is safer and more responsible? There's a technique where you could do safety context, where you tell the model in the prompt, if it thinks that the prompt is harmful, then it should refuse to answer the question. Now, the problem with this is that it refuses to answer the question for harmless prompts as well. So safety context distillation is a slightly more advanced version of this, where you take the data generated by your model for this prompt, and then you fine tune your model on that data for some time. And what does that do? Well, safety context distillation works quite well, and it helps the model to be safer while still being fairly useful. So this is in the blue is the Aya model, which doesn't have any sort of safety mitigation, and then the green is Aya safe. And this is evaluated by GPT-4 and ratio of harmful generations on adversarial bench held out prompts. And this is quite a big reduction for a small penalty in terms of performance. What about toxicity? Here we compare MT0X, the Aya model, and Aya safe. Across most languages, the maximum toxicity is the lowest for Aya safe. For most things, English is a little interesting. I think this was, we thought that what might have been introduced by the safety distillation process, but also the templated data sets had a bunch of, I guess, toxic data in there that could cause some of this increased maximum toxicity. In terms of bias as well, we find that Aya safe is quite good across most languages. For some languages, it did vary, but we found that overall, when we sort of eyeballed this, we were producing much better translations with less toxicity for the Aya safe model. Overall, this is sort of very premature and sort of a first step for safety in multilingual models. I was talking about the performance penalty you pay. So there's a small performance penalty that you pay for doing the safety mitigation, but it still performs much better than MT0X on most tasks. Finally, I want to give a moment to sort of thank all my collaborators on both the data set and the model. There are 2 papers that you could go and read, but it wouldn't have been possible for everyone who contributed. We had almost 3,000 people contribute with 56 ambassadors from 119 countries. So it wouldn't have been possible without any of them. And yeah, I think, thank you. These are sort of our links where you can go to find out more, and sort of the Hugging Face URLs for the data sets and the model. That is me.
Thank you, Viraat, and thank you, Shivalka and Ramith. So I'm going to actually open it out for folks in the audience who might have questions. I am going to, the part where I was going to ask a couple of questions, I'm actually going to skip since we are pressed for time. Anybody, if you have questions, just raise your hand and I'll point and y'all can go. Yep, Dan.
Hey guys, thank you for your time firstly, and for explanation of the paper. I think it was a very great explanation of like quite a lengthy paper you published, and great work. So I think I just had a curiosity in terms of this is a question, I think, on your opinions as scholars on multilingual, language models at large in general. I think so. In terms of what the broader goal of Aya was to democratize or make accessible the language-rich usefulness of English, right? And I think there's always saying, I hope it didn't ruffle any feathers, but I think it goes as to the context or constraints within a certain language's vocabulary that, for example, you may be able to defend Sinhala in Marxism, but you cannot defend, can defend Marxism Sinhala, but you may not be able to do it in English. I'm just wondering, I did catch on how you were fine-tuned and how you accounted for the semantic gaps, because I essentially understand you're still mapping it onto the same sort of vector space back and forth, right? As you're swapping between languages. So do you think there's some level of semantic understanding that multilingual language models at some point that it will peak? And if so, where do you think this limit is? And to what extent do you believe this particular approach can take it to the maximum, assuming we have no resource constraints in terms of contributors, open all sorts of open source contributors. Imagining a world with no resource constraints, where do you think the ceiling on this is, and where exactly does it end on what the extent of what we're able to do with the multilingual model? If that makes sense. Thank you. I think that was just whoever wants to answer from the panel.
Yeah, maybe I can take that in. And Ramith and Shivalka, if you have any thoughts, feel free to add. But yeah, I think the main resource constraint right now is high quality data for the large number of languages. And if that was taken away, then your resource constraint becomes capacity of your model. So at some point, there's going to be fighting for model capacity based on the language and how much reinforcement. If you take that away as well, I think we will see sort of similar levels of performance across all languages. And so you could expect something like maybe a ChatGPT 4 or something, that level of performance across all languages. In terms of getting to like sort of semantic understanding and those sorts of things, I think there is still a lot of work to be done to see what that looks like for the multilingual space. I think there's been some exploration primarily for English, but whether that carries over to the multilingual space is unclear. I would like to mention cross-lingual transfer. I think that's a very interesting phenomenon. So for example, I think there was a recent work on KMMLU, so Korean MMLU, and they found that the Quen model was the best performance on that. And Quen hadn't even trained on Korean, it was mostly Chinese data. So they saw large cross-lingual performance from Korean to Chinese for that. And so I think those are some interesting things that we're going to be seeing. We saw that as well with Aya, where the low resource language got the biggest lift from sort of our mixture.
Thanks, yeah. I think, yeah, answered my question.
I had a personal question myself. So, in addition to what just Dan mentioned, like after the completion of at least like this part of the project, like what parts are you most like curious about as researchers to explore, in which directions? Like if you were to like extend this work, like what excites you, or like what would you really hope like others will pick up on and do research on?
Yeah, I can sort of go first. It's an interesting question. I think for me personally, I'd be interested to see if we can see sort of vocabulary transfer. One of the reasons we had to go with MT5 was that the vocabularies of a lot of the existing open source or state-of-the-art language models don't include, let's say, Hindi or Arabic or certain scripts. And so that makes it very hard to sort of fine-tune with these newer models. So if you could take, let's say, Llama, which is trained on some 20-odd languages, and sort of have that work for 101 languages, that would be very interesting. I think that's one. But yeah, let the others go if they have any.
Yeah, in terms of future directions, I feel like maybe language-specific fine-tuning. It would be great to see. I mean, language models fine-tuned specifically for Sinhala, Tamil, merging up and if we can benchmark how well it performs. Yeah, the other direction would be sort of like probing into these models to see, like Viraat touched upon it, like cross-lingual transfer, those sort of phenomena. So yeah, it would be, I think Aya 101 model would be a great model to sort of dissect and see what we should do to improve multilingual performance.
Yeah, if I can add one more, I think synthetic data is really interesting right now. So you're seeing lots of synthetic data for math, for code. So getting high quality multilingual synthetic data is an open question. And so I guess you'd need sort of a high quality teacher for that, but does that work well? And what does that data look like is an interesting path.
I do have another question myself, but I'll maybe leave it to others. If you have any questions, we can come on camera and raise your hand if you do have questions. Maybe I think it's both. Just in terms of like an explanation, like what's the, I'm assuming like cross-lingual transfer was like at least one of the assumptions of like why a model like this would perform better. Like what's the current understanding of like how that works, and why is it important for like the concept of cross-lingual transfer for like a multilingual model like this? I think just in just like a simple explanation, I think would like people in the room would benefit.
Yeah, I think it's not fully explored why cross-lingual transfer happens. I think the intuition that I have across it is that you're taking tokens from a language and then sort of projecting them to high dimensional space. Now, similar ideas probably live somewhere similarly in the space. And that's why you sort of see this cross-lingual transfer, where, and why it's important is because of the data issue. So for lots of languages, you don't have as much data. So these models are pre-trained on large scale internet data, which is mostly high resource languages. And so it is interesting to think about what you'd be able to do if you don't have as much data. So you have a lot high resource language, it learns a lot of concepts, let's say, from the high resource language and is able to easily transfer it to a low resource language. So it doesn't need to start from scratch. For example, and this can depend on context length and things like that as well. An interesting tidbit is for the Gemini 1.5 release. In the technical report, they specify that with the large context length, they're able to give the model a grammar rule book, some example sentences, and a dictionary of a language spoken by 200 people in the world. So this basically doesn't exist on the internet. And the model was able to achieve similar performance as a human's translator. It doesn't mean that it's good, but it's still able to achieve similar performance. And this is like the extreme version of cross-lingual transfer, right? It's seen very small data. It's learning in context, and it's able to produce translations that are of a decent quality.
Sri Ganesh, yes, please go ahead.
Sorry, I won't won't turn on my camera if it's okay. Question here is, I mean, this cross-lingual, first of all, I'm sort of a layman here. So, a lot of what was talked about, probably just went over my head. But, nonetheless, I'm just curious, like, given the intuition that you just mentioned, Viraat, around cross-lingual transfers, etc., if, would there be any guesses for like Sinhala and Tamil, if you are to leverage that in some way to try it out, whether it works, doesn't, what would we might do? Given that, I mean, Sinhala, okay, Sanskrit root, maybe there's commonalities with Hindi, and I'm getting the sense also from what you all have talked today is that it feels like you're almost putting the level of the state of the art for Tamil almost the same as for Sinhala. Maybe I got that wrong. My sense was that, for Tamil, it's a little bit more the state of the art, but, maybe you can sort of just clarify that for me, trying to get a sense of what's the baseline that we would start for in both these languages in the Sri Lankan context. Thanks.
Yeah. Maybe Ramith, do you want to take this? Because I am not fully familiar with sort of the Sri Lankan.
Yeah. So in terms of the cross-lingual transfer question, I think I think as you mentioned, like both languages. I mean, in terms of evolutionary history of languages, there might be definitely commonalities. I mean, when learning Sinhala and Tamil, we come across those similarities. So yeah, so towards that goal, it might be very interesting to sort of maybe train languages on particularly like Indo-Aryan languages, or maybe Sinhala and Tamil only, to like see that phenomena. I'm not aware about exact research that's happened on that aspect. Yeah, so that's about one part of the question. Regarding the model performance, Virat, do you recall, like I think for each language we like mentioned the performance metrics for Sinhala and Tamil. I think possibly Tamil might have better performance metrics, I suppose.
Yeah, I think Tamil was slightly better in terms of the numbers, but I think qualitatively they'd probably be very similar. If I remember correctly, we didn't have any human annotators for Tamil or Sinhala for the evaluation, so we don't have like human quality comparisons, but they're similar. They're both considered low resource according to the classification that we used. But yeah, in terms of model space and things like that, I would imagine that these two sort of live in a closer in that high dimensional space. If I can quickly share my screen, I will show you a picture that a researcher, Christopher Akiki, made. This is of the Aya data set itself, so the data set that Shivalka was talking about. And so each of these colors that you see of these dots is one sentence in the data set. Each of the dots is one sentence and each color is one language. So I think I see Tamil somewhere here. And I see Sinhala somewhere here. So they're fairly close. So they're, somewhat far away from Finnish, Dutch, those sorts of things. So you can see that there is some underlying structure to the data and the way the language is used, which makes it similar to a bunch of these. I won't talk to his research here, but it is interesting.
Just a follow-up on that. Sorry, Ramith, go ahead.
Sorry, this is a small question to Viraat actually. So in the Aya evaluation, where like we had like human curated evaluation for I think six languages, I think. So yeah, I think definitely what's your view on like I think for Sinhala and Tamil, maybe I'm not exactly aware with the literature, but definitely having good benchmarks would be of importance as well, right?
Yeah, I think that's a very, very sort of salient point. One of the things that's unsexy about AI research is benchmarks, but these are some of the things that really drive the field forward. And we've sort of reached a place for English where there's a large number of benchmarks across a different number of categories that are high enough quality that they still push some of the models to the limit. But for multilingual, there is definitely a dearth of this. And this was a part that we tried to address with the eval suite and the sort of large number of evals we did. But a large number of those languages, we cover 99 languages in our eval suite, but a large number of those come from using Flores, which is a sort of translation data set, which has 280 languages. So if you take away Flores, we're down again to 25, 30, and that's where we'd like to see more, benchmarks and evals coming up.
Any other questions? maybe I have a final question on that cross-lingual transfer phenomenon. I'm neither a linguist nor specifically an NLP person, so like forgive my ignorance if the question does not sound very intelligent. But like, does that also mean like if given like where they live, live in that semantic space, like does it make sense for like languages like closer to each other to leverage some of like the fundamental features of languages, and like if you were to like, is it likely that like a few languages which get together and maybe aim for like a multilingual model effort, like but just a few languages that can possibly, is that a direction, would it possibly outperform language? Like if you basically what I'm asking is, if you put the same amount of effort between languages which are potentially like similar, is it likely to outperform like a more generic effort like yours?
Yeah, that's an interesting question. I guess it depends on the quality of the data. So both quality and quantity matter. For the instruction fine-tuning case, you want the highest quality data and on the order of thousands to hundreds of thousands of examples. Your training budget usually allows you to train on maybe a few million examples overall. So per language, that would be the way you'd go for it. In pre-training, you do get multilingual data, but it's mostly large-scale, high-resource stuff, and that's where the way I like to think about it is, in pre-training, you sort of force your model to acquire capabilities that are latent. In instruction fine-tuning, you sort of unlock these capabilities or tell the model how to access them. And so for that use case, yes, maybe you would see better performance if you were more concerted for a particular number of languages. I am also, like, if you, let's say, had a pure Sinhala model that was pre-trained on Sinhalese data and was fine-tuned on Sinhala data as well, I think that would still lag behind a general purpose model that's been pre-trained on a large amount of data from different languages and then has cross-lingual transfer. That's my feeling. I don't know if there's solid research that backs it up. Maybe it's an open area.
Yeah, I think that's all the questions we are going to have. Then, sorry.
Sorry, I just have a very small question because I was very curious about the visualization. It's very interesting, I think. Just a very quick question, and if you could possibly share the paper or the scholar who was to publish that as well, it would be quite interesting. As you mapped it down to 3 dimensions and you're able to view the paths between these languages, do you think that's of any value to anthropological or linguistics researchers? Or is it simply just a more generalized visualization because of the embeddings you're using, that the embeddings are more, thank you, that the embeddings are suited more because the embeddings are built for English, that it's not exactly a direct visual representation, but rather a more representation for the purpose of the paper itself, if that question comes across correctly?
I'm not a linguistics expert, so I'm not sure if this has applications in that area, but the idea is that you take these sentences, you embed them to a high dimension space, and then you use different techniques to project them down to 2D or 3D, I guess you're including color. So I think the particular version used here is a technique called TSNE, TSNE. It is similar to PCA or other so high dimensional to low dimensional methods. It's slightly more involved than PCA, but it's a nice tool to be able to visualize the data and see if there's any sort of underlying structure to it. If that's useful for linguistics research, I'm not sure, but it is nice to see these sorts of patterns emerge from the data naturally without having any labels on them.
I think there's some, those two, maybe previously little bit distinct research areas might be coming together now. I've seen like some papers, linguists analyzing these large language models. Yeah, I think That's definitely a lot of interesting stuff to uncover, I guess.
Yeah, especially in terms of, I guess, when you start talking about synthetic language generation and what it really means as you start to cross the border between what truly does it mean to be synthetic, since language itself, as human language goes in itself, it is synthetic simply because it keeps evolving, right? So at what point do we stop calling that synthetic and this not synthetic? And what a machine is able to generate as well. I think where we draw the border between that in the future would be a very interesting question. But yeah,
From my
thank you for sharing.
I was
Sorry,
talking
yeah.
earlier about sort of model-generated language data, synthetic. In that sense, there's been a bunch of interesting work to show that you don't need such large quantities of data if you're able to generate high quality, and getting humans to generate high quality data is expensive. So you outsource it to a model.
Yeah, exactly. Thank you.
Yeah, I think it's we are almost half an hour into half an hour over the allotted time we had, but thank you. I think it was a amazing presentation and like even an better discussion that we were able to have. So with that, I once again want to thank Viraat, Shivalka, and Ramith for agreeing to do this and just explaining your motivation and what you followed and potentially like what lies ahead for languages like Sinhala and Tamil. This marks the first of a series of sessions that we want to do around issues of AI for social good. So we will keep everyone posted on our social media regarding our second session. And thanks for joining, and see you at the next one.